Here we have a SAT math problem. Let's go with the information. The kinetic energy of an object is given by 1/2 times mv square, where m is the mass of the object and v is its velocity. A radioactive element loses 15% of its mass and 20% of its velocity. By what percentage has its kinetic energy decreased? Okay, so here the formula for kinetic energy is given. Since this is a formula 1/2 times m times v square is the formula for kinetic energy, we can take that one as k. That is k equals to 1/2 times mv square. Okay, so the information says a radioactive element possesses 15% of its mass. So m becomes, so it loses 15%. It's, I have to subtract 15 from 100 percentage of m. Okay, we can convert this one like 100 minus 15 is 85% of m. 85% can be converted to decimal. It will become 0.85. O of means it's times m. So 100 minus 15 is 85, 85%. So 85% can be converted to decimal by taking 100 as denominator for 85 because we have percentage. So 85 over 100 is equal to 0.85. Okay, now there is one more change. That is the same radioactive element loses 20% of its velocity. So V becomes 100 minus 20% of V. Just a moment. Okay, so 100 minus 20 will become 80, 80% of V. 80% can be converted to decimal. It will be 0.80 or simply 0.8 times V. Okay, so when the element loses 15% of its mass and 20% of its velocity, by what percentage has its kinetic energy decreased? So now I'm going to find the new kinetic energy after the two changes, that is 15% loss in mass and 20% loss in velocity. I'm going to find the new kinetic energy. So new kinetic energy can be written as new k equals to 1/2 times m has to be replaced by 0.85 m. And V has to be replaced by 0.8 V. So the whole square, because we have square for V, so we have to square 0.8 V. So it's a calculator section. So if I want, I can use calculator in this question. So 1/2 times 0.85 times m. And we have square, actually we have 0.8 and V are multiplied and we have square. So the square can be distributed to 0.8 and V, so 0.8 square times V square, 1/2 times 0.85 times m times, when I square 0.8, it will be 0.64 times V square. Okay, now we can multiply this 0.85 and 0.64. Let's multiply this. So when I multiply them, I'll be getting 0.544. I can write that value in front of everything. So I'm writing the product of these two values over here. So the rest is 1/2 times m times V square. So here it's a decimal. If I convert this one to percentage, I have to multiply this one by 100. So if I multiply this one by 100, the decimal point has to be moved 2 digits to the right. Then it will be 54.4% of 1/2 times mv square. So 1/2 times mv square is the original kinetic energy. That is of K. So after the two changes, the kinetic energy, the original kinetic energy becomes 54.4% of the original kinetic energy. So they are asking us to find by what percentage the kinetic energy decreased. So the original kinetic energy always to be assumed as 100%. Once again, the original kinetic energy has to be assumed as 100%. But now, after the two changes, that is 15% loss in mass and 20% velocity, the kinetic energy, original kinetic energy becomes 54.4%. So what percentage it has when the original kinetic energy is decreased? So we have to subtract 54.4 from 100. So when I do it, so I'll be getting 45.6. So the decrease is going to be 45.6. So when the radioactive element loses 15% of its mass and 20% of its velocity, it decreases its kinetic energy by 45.6%. So the correct answer choice for this question is option D.